To troubleshoot a QWERTY ground fault detector, firstly, ensure that the equipment is powered off and locked out. This is a critical safety step. Verify the wiring of the detector and current transformer sensing unit according to the manufacturer's instructions. Incorrect wiring can lead to false trips or failure to detect ground faults. Secondly, power on the equipment and measure the current draw on all phases using a clamp meter. Record the current values for future reference. This baseline helps identify imbalances that could indicate a ground fault. Thirdly, observe the detector's display or indicator lights to determine the trip condition. If the display indicates a ground fault, proceed with the following steps. The display provides valuable information about the nature of the fault. Fourthly, to locate the ground fault source, consider using the loop current method. Use a clamp meter to measure the current on each phase conductor leaving the detector. Start at the farthest point in the circuit to work your way back towards the detector. The conductor with the lowest current, or no current, is likely the source of the ground fault. This method relies on the principle that ground fault current returns through the grounding path, creating a difference in current between the phases. Another method is the injection method. Connect an appropriate current injection probe to the neutral conductor at the detector. Increase the injected current gradually while monitoring the detector's display. The fault will typically trip the detector at a specific injection current, indicating the location of the fault. This method introduces a controlled current to simulate a ground fault, helping to pinpoint the fault location. Fifthly, once the ground fault source has been identified, inspect the conductor, connections, and equipment at that location for damage or installation issues. Make necessary repairs and ensure proper grounding. Common causes of ground faults include damaged insulation, loose connections, and equipment failure. Sixthly, once the fault has been cleared, reset the ground fault detector according to the manufacturer's instructions. Verify that the detector is operating properly by monitoring its display or indicator lights. Proper resetting ensures the detector is ready to respond to future ground faults. Ground fault detectors must be tested periodically to ensure proper operation. Regular testing confirms the detector's functionality. If the ground fault detector continues to trip intermittently, consider consulting an electrician for further troubleshooting. Intermittent trips can be challenging and may require specialized expertise. Always follow all safety precautions when troubleshooting electrical equipment. Safety is paramount when working with electrical systems. The loop current method involves using a clamp meter, which is also known as an ammeter, to measure the current flowing in each phase conductor. The principle behind this method is that in a balanced three-phase system, the sum of the currents in the three phases should be zero. However, when a ground fault occurs, a portion of the current flows through the ground path, causing an imbalance in the phase currents. By measuring the current in each phase, you can identify the phase with the lowest current, which is likely the phase where the ground fault is occurring. Start by clamping the clamp meter around each phase conductor, one at a time, at the furthest point from the ground fault detector. Record the current reading for each phase. Then, move closer to the ground fault detector and repeat the measurements. Continue moving closer and closer until you identify the phase with the lowest current. The point where the current is the lowest is the location of the ground fault. The injection method involves injecting a small amount of current into the neutral conductor of the electrical system and monitoring the ground fault detector. The principle behind this method is that when a ground fault occurs, the injected current will flow through the ground path, causing the ground fault detector to trip. By gradually increasing the injected current, you can determine the point at which the ground fault detector trips. The location of the ground fault will be close to the point where the injected current is causing the trip. To use the injection method, you will need a current injection probe, which is a device that can inject a controlled amount of current into a conductor. Connect the current injection probe to the neutral conductor at the ground fault detector. Set the current injection probe to inject a small amount of current. Gradually increase the injected current while monitoring the ground fault detector. When the ground fault detector trips, note the amount of injected current. The location of the ground fault will be close to the point where the injected current is causing the trip. When inspecting for damage or insulation issues, pay close attention to areas where the conductors are exposed to mechanical stress, heat, or moisture. Look for signs of cracking, melting, or discoloration of the insulation. Also, check for loose connections, which can cause arcing and ground faults. Ensure that all grounding connections are secure and properly installed. Proper grounding is essential for preventing ground faults and ensuring the safety of the electrical system. When resetting the ground fault detector, follow the manufacturer's instructions carefully. Some ground fault detectors require a specific sequence of steps to reset properly. Verify that the detector is operating properly by monitoring its display or indicator lights. The display should indicate that the detector is in a normal operating state and that there are no active ground faults. Ground fault detectors should be tested periodically to ensure proper operation. The frequency of testing will depend on the manufacturer's recommendations and the specific application. Regular testing can help identify potential problems before they lead to a ground fault. If the ground fault detector continues to trip intermittently, it may be necessary to consult an electrician for further troubleshooting. Intermittent trips can be difficult to diagnose and may require specialized equipment and expertise. An electrician can perform a thorough inspection of the electrical system and identify the cause of the intermittent trips. Always follow all safety precautions when troubleshooting electrical equipment. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and working in a safe environment. Before working on any electrical equipment, always de-energize the circuit and verify that it is de-energized using a voltage tester. This will help prevent electrical shock. The National Electrical Code, or NEC, provides guidelines for the installation and maintenance of electrical systems, including ground fault protection. Consult the NEC for specific requirements related to ground fault protection in your application. Understanding the principles of ground fault protection is essential for troubleshooting ground fault detectors effectively. A ground fault is an unintentional electrical path between a conductor and ground. Ground fault protection devices are designed to detect these faults and quickly interrupt the circuit to prevent electrical shock and fire hazards. Ground fault detectors typically use a current transformer, or CT, to monitor the current flowing in the conductors. The CT senses any imbalance in the current, which indicates a ground fault. When a ground fault is detected, the ground fault detector trips, opening the circuit and stopping the flow of current. The sensitivity of a ground fault detector is determined by its trip level, which is the amount of current that must flow through the ground path to cause the detector to trip. The trip level is typically expressed in milliamperes or milliamps. Ground fault detectors are available with a variety of trip levels depending on the application. For example, ground fault circuit interrupters, or GFCIs, which are commonly used in residential applications, typically have a trip level of 5 milliamps. Ground fault protection is required by the NEC in many applications, including bathrooms, kitchens, and outdoor areas. Ground fault protection is also required for certain types of equipment, such as electric heaters and air conditioners. When selecting a ground fault detector, it is important to choose a device that is appropriate for the application. Consider the trip level, the voltage and current rating, and the environmental conditions. It is also important to choose a ground fault detector that is listed by a recognized testing laboratory such as Underwriters Laboratories, or all. Proper installation and maintenance of ground fault detectors are essential for ensuring their effectiveness. Follow the manufacturer's instructions carefully when installing a ground fault detector. Regularly inspect the ground fault detector for signs of damage or wear. Test the ground fault detector periodically to ensure that it is operating properly. Troubleshooting ground fault detectors can be challenging, but by following a systematic approach, you can often identify and resolve the problem. Start by gathering information about the problem. When did the problem start? What are the symptoms? What has changed since the problem started? Once you have gathered information, you can begin troubleshooting. The first step is to verify that the ground fault detector is properly installed and wired. Check the wiring connections to ensure that they are secure and that the wires are properly sized. Verify that the ground fault detector is properly grounded. The next step is to isolate the problem. Disconnect any equipment that is connected to the circuit and see if the ground fault detector still trips. If the ground fault detector no longer trips, then the problem is likely with one of the pieces of equipment that you disconnected. Connect each piece of equipment back to the circuit one at a time until the ground fault detector trips again. The piece of equipment that causes the ground fault detector to trip is the source of the problem. If the ground fault detector continues to trip even after you have disconnected all of the equipment, then the problem is likely with the wiring in the circuit. Inspect the wiring for signs of damage or wear. Look for loose connections, frayed wires, and damaged insulation. If you find any problems with the wiring, repair or replace the damaged wiring. Once you have identified and resolved the problem, test the ground fault detector to ensure that it is operating properly. Reset the ground fault detector and see if it trips again. If the ground fault detector does not trip, then you have successfully resolved the problem. If the ground fault detector continues to trip, then there may be another problem with the circuit. Consult an electrician for further assistance. The following are some additional tips for troubleshooting ground fault detectors. Firstly, use a clamp meter to measure the current flowing in each phase conductor. This can help you identify imbalances in the current, which can indicate a ground fault. Secondly, use a megameter to test the insulation resistance of the wiring. This can help you identify damaged insulation, which can cause a ground fault. Thirdly, use a circuit tracer to trace the wiring in the circuit. This can help you identify any loose connections or damaged wires. Fourthly, consult the manufacturer's instructions for the ground fault detector. The manufacturer's instructions will provide specific troubleshooting steps for the ground fault detector. Fifthly, if you are not comfortable troubleshooting electrical equipment, consult an electrician. An electrician has the experience and knowledge to safely and effectively troubleshoot ground fault detectors. Ground fault protection is an important safety feature in electrical systems. By understanding how ground fault detectors work and how to troubleshoot them, you can help prevent electrical shock and fire hazards. The continuous tripping of a ground fault detector indicates there is a persistent leakage of current to ground. This leakage could be due to various factors, including insulation breakdown, moisture ingress, or faulty equipment. The troubleshooting process requires a systematic approach to isolate the source of the ground fault. When troubleshooting, it's important to consider the age and condition of the electrical system. Older systems are more prone to insulation breakdown and other issues that can lead to ground faults. It's also important to consider the environment in which the electrical system is operating. Humid or corrosive environments can accelerate the deterioration of electrical components. Regularly scheduled maintenance and inspection of electrical systems can help prevent ground faults and ensure the safety of personnel and equipment. This includes visual inspections, insulation resistance testing, and ground fault detector testing. Accurate record-keeping of maintenance and inspection activities is essential for tracking the condition of the electrical system and identifying potential problems early on. Remember that working with electrical systems can be dangerous. Always follow proper safety procedures and consult with a qualified electrician if you are not comfortable performing any of the troubleshooting steps. The purpose of a ground fault circuit interrupter, or GFCI, is to protect people from electrical shock. It does this by monitoring the current flowing through a circuit and quickly interrupting the power if it detects a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. Even a small amount of current can be dangerous or even fatal. GFCIs are designed to trip when they detect a ground fault of 5 mA or more, which is a level that is considered to be safe. GFCIs are required by the NEC in many locations, including bathrooms, kitchens, and outdoor areas. They are also commonly used in construction sites and other areas where there is a risk of electrical shock. There are two main types of GFCIs: firstly, receptacle GFCIs, and secondly, circuit breaker GFCIs. Receptacle GFCIs are installed in place of standard electrical outlets. Circuit breaker GFCIs are installed in the electrical panel. Both types of GFCIs provide the same level of protection. To test a GFCI, press the test button on the GFCI. This should cause the GFCI to trip, which means that it will interrupt the power to the circuit. If the GFCI does not trip, then it is not working properly and should be replaced. To reset a GFCI, press the reset button on the GFCI. This will restore power to the circuit. If the GFCI trips again shortly after being reset, then there is likely a ground fault in the circuit. It is important to address ground faults as soon as possible to prevent electrical shock. If you are not comfortable troubleshooting electrical equipment, consult an electrician.